So for this question, we have a graph, and we'll start right off with Oizerga. And so our origin, 0, 0, we're good. Y-axis is d, which might be distance or displacement. The x-axis is t, time. And the intercept, yes, we have a y-intercept, which is 0. So that means that at time 0, the distance or displacement is 0. The x-intercept, there is also a 0. So at time t, we have a 0. We can read the quantities d and t. The gradient is delta d over delta t. And if this is displacement, then it's meters per second. So it would be the velocity. The area would be d times t. So meters times seconds, meters seconds. So that's not a quantity that we would look for. So the ball is thrown vertically upwards. The graph shows time and displacement. So indeed it is distance or displacement time. Which one gives the final displacement after time t and the average speed? So we'll look at each one. The final displacement after time t. So when we look at the graph, the displacement increases to a maximum value, and then it decreases back to 0. So after t, the displacement is 0. So that means we eliminate choices C and D. And then we want to know what is the average speed between time 0 and time t. Average speed, we're going to go right to our definition, is going to be delta x over delta t, the displacement divided by the time. It's also the initial plus the final over 2. So if we look at the time is t. So from 0 to t is t. And the delta x, well, the displacement we just said is 0. So the average speed must be 0. That's why the answer is choice A.